Hi everybody, I'm Steve Billow, President here at Desktop Metal, and welcome to the Desktop Metal production system, designed to be the fastest way to 3D print metal parts. It wouldn't be much of a production system if we didn't have speed. If we could only produce a few hundred parts per month, that doesn't make much of a production system. So what we've done is focused on how to get the most efficiency out of the binder jet system. At the core of that is what we call single pass jetting. It's through single pass jetting, SPJ, that we deliver 12 liters per hour of parts printed out of this machine, designed to be the fastest way to 3D print metal parts. Now, single pass jetting is the consolidation of a bunch of different technologies that I'm going to tell you about right now. First, it's about powder. We learned a little while ago that in order to get consistent parts, you've got to have consistent powder. And so what we see all around us is what we call the powder processing unit. That unit's job is to deliver consistent powder to the printer. Once it's delivered to the printer, we put the powder into what we call micro hoppers. So as part of our system, we convey on every pass, we carry along with the carriage metal powder that we dispense very precisely across the bed. So that's a little bit different than some of the other binder jet systems out there. They'll start with a pile and then spread it across the entire bed. Rather, we meter out a constant rate, we call it constant wave spreading. Once we've dispensed the powder, the next step, right behind the micro hopper, is a compaction roll. So we take the powder, we spread it, and we compact it to produce the final layer that we want to print on. The next step we call anti-ballistics. So anti-ballistics is a technology to control the powder. So once we place the powder, we want it to stay where it is. Anti-ballistics will keep that powder there. When we start jetting binder on top of it, it will stay put and it won't come back, hit your print heads. The final step of the process is actually jetting the binder. And so this is where we create the geometry for each layer. Once we finish all those steps, we start all over again. We drop the build box, produce a whole new layer, and layer by layer, we create an entire build box full of parts. The next step of the process is called cross-linking. To make the binder as strong as possible, we put it into an oven to activate the binder. So that creates really strong brown parts that are ready for the deep powder station. Coming out of cross-link, you can see here's a build box. So inside of here are parts nested, ready for deep powdering. Here's an example of one part, and you can see they're pretty strong. You can handle them, but it's not metal yet. It's just metal held together with our binder, so you can break them. We'll take this box, we'll go into the deep powder station, excavate all of the parts, and get ready for sintering, where we do full consolidation of the powder into a final metal part. As you can see, we've moved into our furnace room. This is where the final step of the process, sintering, happens. Sintering is how we take the powdered metal and consolidate it into its final solid metal form. And as you can see, we've got some pretty big furnaces. These industrial furnaces are what you're going to need to keep up with the speed of the production system. And if we take a peek inside, you'll see that the retort is full of production system printed parts. So we talked about speed, but to be a good production system, you need quality and you need consistent quality. So we've got a bunch of things built into this printer to do just that. First, we talked about constant wave spreading. That's really important to give a consistent bed density across the entire bed. If you have density variations within your bed, you end up with parts that vary after sintering. Another key component are the print heads that we chose. So in one pass, we will address the entire bed, and we do it at 1200 DPI with the most advanced industrial inkjet printhead available on the market today. So this thing is designed to last. Another key aspect of quality, we actually have a camera system that monitors in real time both the print bed and the binder that we're depositing on top of the bed. We actually image every layer of every bed with 2 different angles of light. It lets us detect if there are any defects in the bed and how well the binder was deposited on top of the layer. And here's a live image of the layer that's being printed. You can see where the binder is being located. We use these images to detect any problems and make sure we flag the operator if we see anything out of the normal. Another key consideration for a production system like this is cost. So we talked about speed, we talked about quality, but we've got to deliver part costs that's attractive in the end. So one of the key decisions we made early on was to make production system an open powder system. What that means is that you can use your own powders, you can use powders sourced through traditional supply chains. Powder metallurgy has been around for a long time. There are existing suppliers, and by using the production system, you can get the most economical powder available. Now, this open powder system means you can take your own powders, design a process that works for your powders. And we've produced another system called the P1 that's there to facilitate that kind of development. It's a smaller R&D machine, uses the exact same software, all the same steps that I talked to you about, and all of the recipes that you generate on the P1 are directly transferable to the P50. So you do your design work on the P1. As soon as you're done, you transfer it over to the P50 and you're ready to go. Now, one of the things you'll notice is that the chamber for the printer itself is sealed. And we actually have a gas management system that maintains the environment inside the print chamber at all times. It also enables us to use an inert environment. That means that we can safely produce metal parts using powders that are reactive, things like titanium and aluminum, all through a closed environment that's inerted, along with our powder processing unit, which itself is closed and can be inerted as well. So the production system enables you to do things that you just couldn't do before. Not only does it compete from a part cost perspective with traditional ways to make metal parts, it enables you to do all kinds of different things that you can't do without additive printing. So Desktop Metal's production system ushers in a whole new way to make metal parts